Hello everyone. This is a project that Josh and I have worked on since the beginning of the year. Our goal was to create a mathematically animated flag to celebrate the National Day. Because Josh is in JC1, we have limited our scope to use only the A-level math syllabus. This is not a detailed tutorial, but I will explain enough to show you why something like this is possible. I hope our project gives you some inspiration. By the way, all the animations in this video are also mathematically created using the same approach, but they require more advanced mathematics than the flag. I now hand it over to my AI assistant to do the presentation.
A screen consists of many pixels. Each pixel is identified by its x and y coordinates, which tells us where is the pixel relative to the origin. To paint a circle on this screen, we construct a math formula which turns the x and y coordinates into a value d. We do this for every pixel. Our math formula may produce a different d value for each pixel. Then, we use d to decide what color to paint each pixel. For example, when d is positive, we paint the pixel blue. Otherwise, we paint it white. If our math is correct, we can produce a meaningful picture on the screen. Computer screens has very small pixels, which gives us smooth curves. A small change in our formula can produce interesting changes to our shape. We can shift it, shear it, duplicate a mirror image, and shift the images back to the middle. With many small changes to the formula, we can eventually paint shapes like hearts, crescents, and stars. However, the final formula can look complicated even though every step of the way we are just making small changes. But essentially, we now have a math formula that maps each point on the surface to the patterns and colors of this emblem. Later, you will see how we use this formula to create a three-dimensional flag. Here are two spheres painted on a pixelated screen. Let's find out how to paint a 3D picture. First, imagine that our screen is placed within an imaginary world that we have created using math. This world exists only in our mind, and right now there is nothing on the screen. We can make this world look more realistic by using more complicated math. Then, we imagine lines passing through each pixel and hitting some objects in the imaginary world. We paint each pixel according to what the lines hit. Do this for every pixel. The lines associate every pixel on the screen with a point in our imaginary world. Then, we imagine arrows pointing out of the surface, where the lines hit the objects. We darken the pixels by comparing how much the arrows point away from the sun. Do this for every pixel. When the pixels are very small, we get a smooth picture. This is how we create a three-dimensional flag. Use calculus to create a coordinate system on a bumpy surface. Bring back the 2D flag we created earlier. Set up a one-to-one mapping to paint the flag on the bumpy surface. To animate the flag, include time as an input to our formulas. Finally, we add multiple sine waves at various frequencies to create wind turbulence. Trim the boundary and we are done.